We're gonna talk about midterm at the end of class when more people will join us, because definitely we should have some discussion. And of course, I'm not allowed to do this by email, especially talking about grades, why you got a C instead of D, or A instead of B, or B instead of A, or whatever. So we can, of course, talk about this in a very detail. The only thing I want to tell you that when I graded the midterm, I was in extremely good mood. So I was trying to give as high grade as possible. And you will see if somebody has any questions about the particular test, I'll definitely uh, talk about it in very detail. So no problem. Of course, no worries. So at this stage, I want to tell that grades are on the blackboard. So those people that didn't see a grade on the midterm, please check Blackboard. There's also updated grade for the class. So there is a class grade and then the grade for the midterm. So there are two letters in there. And grade for the class also includes, besides the midterm, your homework, and it also includes your quizzes. Remember, there are three parts in the grade: quizzes, homework, and the midterm. So if someone took no quizzes and well, get a good grade on the midterm, well, it doesn't mean that it's a perfect grade for the class. So that's another thing to realize, because quizzes is what we do on daily basis. So we need to be here, you need to take quizzes. So you need to make up for quizzes if you happen to miss it. So that's the idea. And I always give you a chance to do the makeup for quizzes or just get those extra points. And some people take advantage of it, and that's very smart. So I always support your extra credit activities. So if you did not have a chance to email me your homework, please do so. Yes, I will accept it. And even if it's late, well, do it and send me what you have at this moment by email. Most likely it will be good enough. So don't be shy. Email me your homework over the weekend if you did not email it to me as of yet. You don't have to email it to me second time. I noticed that some people love to email me the same thing twice. So don't do that. That's okay. But when I ask you to email me your homework, don't get upset. Maybe you did. Maybe you already sent me your homework. Maybe I just didn't receive it, because sometimes people email it to the wrong email address. For some reason, I noticed some students use, instead of mdc.edu, for me, some like my mdc.net, some type of email address that I don't have. So students have one type of addresses and the instructors here have the other type. I have no idea why. It is confusing, I know, but please make sure you send your emails to my email address that I give you in the syllabus. I give it to you everywhere. I actually emailed you from that address. The recordings of this lecture will also be emailed to you from this email address. So use that one. Don't start to create some other email addresses that do not exist and send the email to them. And when I ask you to send me your work, you get mad and say, Alex, what are you talking about? I already sent it. Well, make sure you send it to me, not to somewhere, right? So that's important. If you take an online class, make sure that you clearly submit your work by email. It's a part of it. You signed for email for online class, so you should be able to send those emails. I know some people need to learn, internet is not working, other things happen. That's why I always give adjustment. That's why I always give you a chance to resubmit your work. So one should really be appreciate that, not to get upset. So think about it. My goal is not to make you upset. My goal is to help you to get a good grade. So I guess that's important to realize. So anyways, we'll talk about all that at the end of class. Looks like more and more people joining us, and that's great. So today's goal is to finish up with section 3.7, the one that we started to talk about last time, and then we'll discuss the midterm. So in the section 3.7, there are two interesting expressions. One of them looks like permutations. So they say from n, they choose x or whatever. And that's what we use when order is important. So when you have order, when you say yes to the order. And sometimes order is not important. That's when you use combinations. So that's the main idea where the difference is in between of those. So if you have order or if you don't really care about the order. For example, if you're playing the lottery game, the order in which you select the numbers is not important. So it doesn't matter if you selected 1, 2, 3, 4, 5, 6, or if you selected 6, 5, 4, 3, 2, 1. You still selected those numbers, and the lottery ticket has those numbers, so they don't really order those. And that's the reason why when I do the exercise 11, I use combinations that says out of 59, you select 6 numbers. So you choose 6 out of 59. And in this exercise, they want a probability. So you get a fraction. So the total number of selections is that many, to choose 6 out of 59. And to win, well, there is only one chance to win. It's guessing only that particular set of numbers. So what I do is I put 1, and then I divide this. And then in denominator, we go to functions, right? Remember main, that's where numbers are, and then functions. And then combinations. Remember, it's on the very bottom here, the combinations. So you get this combinations to select. And out of this combinations, now I go back to main because I need to put my numbers, 59,6. 59,6 parentheses. And we get some very, very, very small number. Please notice the power of -8 means that decimal needs to be shifted not just once, but 7 more places. So these 7 places that we shift this means that we need to fill the empty spots with 7 zeros in front of my decimal point. So the actual answer is something like 0.0000. When you see such a small number, the person that knows statistics will say, no way I'm gonna participate in this, because it means there is no chance that I'm gonna win. But some people actually participate and they actually win, as they say. Well, who knows what's in reality, because they usually say, oh, that person won, but now this person is broke. So managed to waste, say, 800 million in 5 days. It sounds like a truthful story. So anyways, or in 5 years, try to spend that much. It'd be kind of challenging. So unless you decide to go to Vegas or someplace else and they just waste it right away. So that may be a possibility. But anyways, so the idea was that we don't care about order when we play the lottery game. So when do we care about the order? Well, when we start to arrange your selected subjects, and this arrangement is important. So let me find the number here. For example, 19, exercise number 19, which does make difference. So it talks about flying the airplane, and the airplane connects 8 cities. Wow, that's an airplane. So it does make difference if you went from Miami to Austin or you went to New York, because you ended up in totally different place, right? So order is important when you having this 8 cities arranged. 4 is another. So if you go to say A, B, C, all the way to Miami, let's say, whatever. So point of story that you're selecting out of 8 cities in exercise number 19. Looks like all of them. So they say the plane connects all of the 8 cities. So find here how many routes are possible. Well, since order is important, then I have to use a permutations. And out of 8 cities, the airplane serves, the airplane actually makes 8 stops. So goes there, there, and so forth. So of course it makes difference if you start to switch cities around in that particular route. Well, the route is not going to be the same. So permutations. And there is one difference with the previous exercise. They don't ask about probability. So they don't care about the fraction. They just ask you to, well, calculate the total number of routes. So let me find those permutations, and you know where to find. So you go again to functions on this calculator. I say, Alex, what does this calculator mean? Well, that's the one that I found online for free, the Desmos. I can, of course, share the link to this calculator in the chat. So this is going to be the link. You can click on it and you will get that calculator. So let me clear this mess a little bit. It's just not nice. So we have this functions to click on. So I go to select this function menu. And then when we select functions on the bottom, we'll see permutations next to the combinations right here. So you click on this permutations, and then you go back to main, and then you go 8, 8, and then put parentheses. And notice it's a 40,000. That's a lot of possibilities to connect these cities with different routes. So that's 40,320. And we actually saw that intuitive way to solve this will be to say on the first position, I have 8 cities. On the second is 7, because I already went to 1. I don't go there again. And then 6 remain, then 5 remain, then 4 remain, right? Etc. All the way to 1, which is nothing else but 8 factorial. And that's actually the same thing. So if you decide to double check, if you put just 8 and then go back to functions and find factorial next to your combinations, you will see it's the same thing. So that's an intuitive way to do this exercise. Please notice that answer is the same. And to me, it doesn't matter how you solve this problem, as long as you, first of all, have that answer. And the second, if you're on the midterm or final, you should show me your work, right? In some problems, maybe there is no work needed, but in some problems, a lot of work is needed. So you want to show me all that work. Don't just give me the answer. So that's another important thing. I know that some people produce some type of answer, but never shown any work to it. But I ask you to show me work. So if you're trying to get an excellent, excellent means A, right? B is good. Good is good, but not excellent. It's good, but it's okay. It's okay, but there's still something, so it's not excellent. See the difference? Good means everything is okay, but it's not excellent. A is an excellent. So you want to get an excellent? Well, show me the work, right? That's what I wrote. So that's for the excellent results. A C is satisfactory, so it's satisfied, but here and there you made a little mistake. There something is, well, there's no work in the third problem. So that means it's okay, yeah, it's passing, but it's not good, it's satisfactory. Okay, that's fine, you pass. See, that's the difference, and that's important to realize. Some people say, Alex, why did I get a C, not an A? Well, maybe you should thank me that you didn't get a D. But no, I'm not trying to make any threats, but I'm just kidding. But the point of story that if you shoot in for a higher grade, make it look excellent. That's the point. I can give you a chance to get a better grade on this midterm if you want to. Redo it over weekend. I'll let you retake this midterm over weekend and send me an excellent work. I don't mind to raise your grade. I just want you to understand what it means to get a better grade. So you really want to put a little bit more effort. I'm fine with this. I have plenty of time to grade. I can spend my extra time to do your extra credit work. It's fine. So if you, let's say you got a B, but you believe that you're an excellent student, I'm totally down with that. So just send me your work. I will look at it and I'll raise your grade by 1. So instead of B, you can get an A. Instead of C, you can get a B. Instead of D, you can get a C. So that's the whole point. If you now understand what excellent means or what good means, well, do this better and I will raise your grade by 1. I think it sounds like a good deal because I don't want somebody be upset and feel that something is unfair. It's okay, maybe you made a little mistake or forgot to show me your work or whatever else happened. You came from work at night, at midnight, and took this test, you were totally tired. No, I don't want you to lose points because of other circumstances. So over weekend, I hope you will have plenty of time so you can wake up in the morning and retake this test on a piece of paper and send it to me, and I will be more than happy to raise your grade by 1. I think it'd be fair, right? So no problem. You can do this if you want to. If you don't want to, if you got a B and you say, oh, Alex, I'm fine with B, you don't have to do it. You're fine. So that's okay. So I give this option to those people that want to get a better grade. I'm totally fine with that. So please understand again, I'm trying to help you. I'm not trying to downgrade someone. But anyways, as promised, I will definitely look at your test at the end of class and we will see what happened. And if you think that I didn't grade it correctly, I will, of course, fix that. But usually it goes the other way. Usually I give you too many points. That's something that usually happens. But again, we can definitely double check that. No problem. So today I will stop the class without a quiz and we can take a look at various, where's the book? Various tests if you want me to look at them. And right now, I want to say a few words about section 3 of chapter 4. So I want to skip section 4.2. So we'll never do section 4.2. We move to section 4.3, which is opened here. I say, what about 4.1? Well, remember, section 1 of every chapter has no exercises at all. Section 1 of every chapter is actually not empty, it's just like little paragraph that talks about preliminaries for entire chapter. So that's why I don't really ask you to do any exercises from it. Yes, it's good to read, but most people don't read it, and it's fine. So anyways, section 4.3 has a formula. And that's what I want to take a look at right now. I just want to do a few exercises that utilize this formula just to clarify what it actually stands for. I just want to introduce you with this formula. So it says, if you're trying to find probability for some very special experiment, then it's going to be using these combinations that we're already familiar with. So it's choose X from, I think it's a misprint here, it's X, and then P and Q, they're complements of each other. P and Q are like one and its complement. For example, when I see P 0.02 and Q 0.8, notice that if you want to produce Q out of P, it's a complement, so it's 1 minus P. So if I subtract from 1.2, I get 0.8. It's always like that. So this is a binomial experiment. Binomial means 2 times, only 2 possibilities, either success or not a success, which means failure. For example, you guess the answer on multiple choice test. And out of 5, there is only 1 correct. So that's P, that's a chance that you guess correctly. And Q is going to be, well, remaining 4 out of 5, the complement. So 4 wrong answers. Let me say, what are you talking about? Well, if you took multiple choice tests, they usually have 5 possibilities. And you need to bubble just 1 of them. So let's say you bubble D. Well, if D is a correct answer, there's only 1 out of 5. So the chance that you guessed it, it's 1/5. And 4 are not correct out of 5. That's a complement. So for this type of experiment where you can either get success or not, then you have this special formula that applies. So they also say this test has 4 questions. So number of questions is 4. So if you want to put this in a formula, you put 4 here. And notice 4 will be for the power of Q. So your P is 0.2 and your Q is 0.8. Now they ask, how about if you find a probability of 3? So that's exactly 3 correct answers. So you want to answer 3 correctly. So they ask this question. Let's say why? Well, they just need to ask you some kind of question. So instead of X, they put 3, and P to the X will be 0.2 power of 3, and 4 minus 3 is the power is here. And that's exactly what they're calculating. So I can actually go to the calculator and get this put in the calculator. So what I put in the calculator, let me clear this mess a little bit because it's right on the entry line. So looks like in the calculator, I need to put combinations. That's something we already did today. So you need to go to this functions and combinations is here. Then I go back to main and start entering numbers. 4, 3, parentheses. Then I multiply this by 0.2. Now I need to raise it to the power. So how do I raise to the power? Well, here's the symbol, a power of b, remember? So you click on that a power of b, and then you use 3. Then you bring your cursor down, and then you go times, and then 0.8 again, I need the power, 4 minus 3. Well, 4 minus 3 is 1, so you got yourself the answer, which is something like 0.256. Notice to guess 3 correctly is not very high chance. It's about like between 2 and 3%. And that's what they have here in the textbook. Where's the textbook? Here it is. So they have this answer right there. So it's a pure calculator exercise. That's the idea. So in this section, they want you to use the formula. plug numbers in the formula. So if I, for example, try the exercise number 15 here, that says n is equal to 10 and x is equal to 4, and also p is equal to 0.95. The question is, what about complement? What about q? What about 1 minus p? So right away, you need to subtract from number 1, 0.95, which is 0.05. So once you have p, q, n, and x, you can find p of x, which is p of 4, exactly the same way we just did using the formula above. So in that formula, instead of x, I need to put 4. So 4 will go here, here, and here, right? Because x is in the parentheses. So I put 4 here, then the power of p, and then use it for the power of q. Now I need to put p and q. Well, let me put combinations first. So it'll be combinations. Then my p is 0.95, and the q is 0.05. So I put p and q in this formula. And now I need to put another letter n, right? And letter n is right here and right here. So I just replace with 10 my n here and n here. So it's really a straightforward plug-in in the formula. That's really all it is. So I can, instead of plugging this over in, I can just replace in my previous calculation. Look at how I can use the previous formula. So I can just highlight 4, replace it with a 10. I put, instead of 3, number 4, 0.95. So instead of 0.2, I put 95 raised to the power of 4. And q, which is 0.5, right? Now I need to raise it to the power. So you put this power symbol, 10 minus 4. If you don't know that this is 6, if you want your calculator to take care of it, you just put in the parentheses 10 minus 4, just like that. So this is a very small number. You can just copy it the way it is, or you could just move decimal 1 place and 5 more. So there'll be 5 zeros in front of whatever the calculator gives you. 2, 6, dot, dot, dot. That's already plenty of decimals. So very, very small number. So that's what we're going to practice on doing next time. So far, I just gave you a little flavor of section 3 of chapter 4, this binomial experiment, either true or false, either success or failure, this type of experiments that you repeat n times. So you take this, say, multiple choice test, again, next question, again, next question. So let's say it has 10 questions, so you just keep on repeating this. And the question is, how many successes? What's the chance there are 4 successes in here? So you got the calculation. So anyways, more of this will be done next time, next Tuesday. So now I'm gonna end this recording for today. I don't give you a quiz today because I plan to